Hi, in this video we are going to talk about the traverse in order, get the maximum and get the minimum item in a binary search tree. So what about the get minimum value? So we just have to define a get min value function, and basically it's going to have the self as usual. If the self.root, which means that if the self.root is not a none, which means that if there are items, nodes in the binary search tree, then we would like to return with the self.getMin, and we start at the root node as always. So we have this getMin method. Of course, it's going to get a node as a parameter, and if the node dot left child, which means that it is not a none, then we just have to return with the self.getMin. So we recursively call this method on the left child. And anyways, we just have to return with the node.data. Why? We have been talking about binary search trees, and we have come to the conclusion that the left subtree is always smaller than the right subtree. So if we would like to get the minimum value, we have to go to the left as far as possible. So if the node that left child, what does it mean? That it is not a none. What does it mean? That there is a left child, which means that there is a smaller value. We just have to visit that node recursively. And if it is a none, which means that we are at the leftmost item, we just return with that value. Basically, it is the same for the get max. So def get max value with the self, and if self.root, which means that if the tree is not empty, we just return with the self.getMax on the max on the self.root node. Okay, and I'm going to rename it, sorry for that, is not a selg but self. Okay, and then we have to define this method as well. So def get max is going to get a node if node right child. What does it mean? That again, the minimum value is the leftmost item. The maximum is quite on the contrary. It is the rightmost item. So while the node right child is not a none, we just have to return with the self dot get max, sorry for that, get max on the node dot right child. And anyways, it means that we have found the rightmost item, and we just have to return with the node dot data. Okay, let's save it. So as you can see that the leftmost item is the smallest item, this is the 1. The maximum item is the rightmost item, this is the 79. So we start at the root node. If we would like to get the minimum, we have to consider the left node. Is it a none? No, we go to the left. Is it a none? No, we try to go to the left, but it is a none. It doesn't have any left child, so we return with this as the minimum is concerned. The maximum is we just have to do the same with the right child. Is it a none? No, we keep going. Is it a none? No, but the right child is a none, so we know that this is the rightmost item. What about the in-order traversal? We have the def traverse method with the self, and if self.root node again, so if the root is not a none, which means that the tree contains nodes, then we just have to call the self.traverse in order on the self.root. Okay, so we have this traverse in order with the self and the node, and if the node dot left child is not a none, we just have to visit, so call this method recursively, self.traverse in order on the node dot left child, because what we have been discussing in a theoretical section, that the in-order traversal is going to visit the left subtree in a recursive manner, then the root node, then the right subtree. So here we print out the node For example, like this. Data, sorry for that, node.data. And if the node.writeChild, so we keep visiting the right subtree in a recursive manner, then we keep calling this, traverse in order method on the right child. Okay, so basically the right subtree. So that's all about the getMin, getMax, and traverse in order. So that's why we visit the left subtree in a recursive manner, print out the root node, then the right subtree. It's very important that this root node is not the actual root node always, so this is not this, but it may be the root node of the subtree. For example, this can be a root node because this is the root node in this subtree, or this is a root node in this subtree, or it can be a root node because this is a root node if we consider this subtree. Okay, so this is why we print out the root node and left child, or right subtree in an in-order manner. Thanks for watching.